Okay, example 4. It's a similar situation, but we have a different graph here for g of x. A graph that is not constant. So what is the limit of f of g of x as x approaches 1? So if we look at f of x, we notice it is not continuous at 1, or at x equals 2 actually. So it's not continuous at x equals 2 right here. So we have a hole, but g of x does not equal 2 around, keyword is around, x equals 1. So not at, because at x equals 1 it is 2, it's around. So like here, like all in here and here, g of x does not equal 2. It's a little bit lower than 2 here, and it's a little bit higher than 2 here. So this is unlike g of x on example 3b, where it was a constant function where g of x was always 2. This one is not a constant function. So the value is changing around x equals 1. So the limit of f of g of x as x approaches 1 is equal to 1. Because around x equals 1, g of x is not equal to 2. It's a little higher, it's a little lower than 2. So if it's a little higher and a little lower than 2, that means it's here and here. And the limit is equal to 1. This is a 1 right here. Second question is, what if g of x was discontinuous at x equals 1? Okay, so if g of x was discontinuous at x equals 1, let's say if there was a hole here, it doesn't really change anything because g of x still has the same values around x equals 1. Not at x equals 1, around. So keyword around. So it doesn't change anything. The same solution would hold.